Thanks a lot. Thanks everybody for coming. And I'm going to try to do this in such a way that it's not very technical, because I'm hoping that the main thing is just to see what Quine says and then to notice the negation of it as found in Principia. And focusing on Quine in particular because he's very important in philosophy and in the philosophy of mathematics and so on and so on. And he's presenting Principia itself. So it's a bit strange that some of the things he says about Principia are actually not in Principia. In fact, the negation of it is in Principia. So you begin to wonder what the story is on that, and not only of Quine, but of others. And of course, we're going to see in a minute that Russell has a nice lament about people not reading Principia, which looks on the face of it like hyperbole, but which I'm going to suggest may not be so hyperbolic after all, that in fact, either quite a few interpreters actually didn't read it, or they were just trying to be well-meaning and wanted to present what ought to have been in Principia by their lights, not what is actually in Principia. So let's go, we'll take a look, and I would mention that this is in a way a part of the larger work I'm doing, Principia Mathematica Redux. We want to go back and take a look at the actual work, some of the amazing things that are in there. And I don't really know ultimately whether I'll be able to publish this work, because it is rather technical, but in the end, I've been having such difficulty with typesetters in general that I'm beginning to wonder if the talent is out there anymore to typeset these kinds of symbolism. So I might just have to go to open access or something like that. Well, maybe I'll get some advice from some of the participants today on that sort of thing. In any case, we're going to focus primarily on Quine, but there are, of course, many others. And so let me see if I can just change the slide here. There's Wittgenstein, Ramsey, Carnap, Twistic, Gödel, and Church, and many others, in fact, who made important comments and interpretations of Principia, which one and all are pretty readily able to be refuted by simply reading Principia. So there's a constant sort of a mismatch between what people say is in it and what is in fact in it. And this is only just a representative sample. Of course, we want to focus our attention on Quine, but we'll see in a minute that we'll have a brief discussion of some of the others. So here's what I call Russell's lament, and since it's about Principia, I put Whitehead's picture in there as well. I hope everyone can see it. So let me just read this. We've all seen this passage before, perhaps. It comes from my philosophical development, which is fairly late. I think is it 56, something like that. Whitehead and I were disappointed that Principia Mathematica was only viewed from a philosophical standpoint. People were interested in what was said about the contradictions and in the question of whether ordinary mathematics had been validly deduced from purely logical premises. And then he goes on to say, I used to know only 6 people who had read the later parts of the book. 3 were Poles, subsequently, I believe, liquidated by Hitler, and the other 3 were Texans, subsequently successfully assimilated. Now, of course, it's hard to know exactly what he means about this, and there's interesting information about it out in public view. Who these Poles might have been, and what's this story about Texans supposed to be about. But anyway, I don't want to go into that as much as I want to just say that while it looks like hyperbole, it may be far less so than you might have thought. So here's a wonderful picture of Wittgenstein and Russell. And the split between them is really pretty interesting. So I really love this picture. We might start with something that Wittgenstein says about Principia and see the mismatch, or we could start with any one of the others. Here's another thing that I made up. My son made this for me. Totally hopeless. But we've got the two, what you might have thought were disciples, so I put their heads on beside Russell, sort of like the Last Supper. But both of them had views that were really quite distinct from what we find in Principia. So let's start just briefly with a little Wittgenstein before we hit the Quine. So Wittgenstein, in a letter of 1913, notebooks, many of you may know this this particular letter. He says your axiom of reducibility, we could focus on 12.1, is this. Now, is this all not nonsense, as this proposition is only a meaning if we can turn phi into an apparent variable? Apparent variable is the bound variable. For if we cannot do so, no general laws can ever follow from your axiom. Do let me know if there's anything more in it. The axiom, as you have put it, is only a schema, and the real principle ought to be the closure of that schema for all phi. And where would the use be of that? So let's take a look. If we look at this in a little more detail, as a schema, it's actually the schematic nature of 12.1 that gives it all its power. It gives it all the laws that you get, because you can plug in various formulas for the schematic letter phi. And here's an example. We could plug in self-identity, and then we would get that instance, say, in the lowest type. Does my pointer work? I could like point at things if it is actually working. I don't know. Can you see my pointer here at all?
Pointer is working, yeah.
Yep, good. So if we look at this clause, I just plugged in x is equal to x here into the phi position, and we get this result. Or I could put x is not equal to x into the phi position, I get this result. So I get many, many results from the schema, each one of which is taken to be an axiom of the logic. So the power of it comes from it, precisely from its being a schema, not from its being a closed formula. Now, did Wittgenstein not understand? Well, he calls it himself a schema, so it's really puzzling. Following Wittgenstein's claim, let's remove the schema phi and we'll put in a predicate variable, let's say. Suppose there's a predicate variable phi. Let's take one in lowest simple type. And then we would get a W12.1. And now W12.1 would be totally useless, because, of course, it would just follow from an existential generalization on the logical truth that's right here. Everything is such that if it's phi, then it's phi. But this does not yield comprehension of ever new simple types of properties in intension. And to his credit, I wanted to say something positive about Quine. If you read set theory and his logic, he points this out. This is where I first learned this, that we need a schema here and not a closed formula. So I put, there's my Wittgenstein with a little line through it. Now, if we go to Ramsey, we find that he says that 12.1, there's no reason to suppose true. This would be a happy accident and not a logical necessity. For this, it's not a tautology. And so I just want to say briefly there, why should it be a tautology? There must be some background assumptions going on here that would suggest that somehow tautologies or generalized tautologies characterize the nature of logic. There's no reason to believe that at all. We would need to know his background assumptions, and those assumptions might be certainly in conflict with Whitehead and Russell's assumptions about ontology. Twistic takes 20.01, which is the characterization of the no classes theory, and he gives an instance which is false. Now, the Twistic one on the left-hand side here doesn't have its scope operator. And as a result, he gets this instance where a secondary scope would be equivalent to a primary scope, and then he proclaims that we've got a problem on our hands. But the problem is with Twistic, because the scope operator is required, and Russell says so on page 80. So when he puts 20.01 without the scope marker, he's assuming that we have a extensional context, and so that scope wouldn't matter in that kind of extensional context. So once again, it looks like Twistic didn't read, at least he didn't read page 80. Otherwise, he wouldn't have made this kind of mistake. Carnap. Russell's logicism is an extension of Frege's logicism to the whole of mathematics. No, it was not an extension of Frege's system. And in fact, it rejects Frege's logicism, which proclaims that numbers are objects, abstract particular objects in its technical sense. Carnap and Church, star 12 is an axiom, not a schema. Okay, we've seen that that's false, and it reduces orders, and PM has a ramified syntax of orders and types, where predicative means the order of the lowest, the lowest compatible with the simple type. No, as we'll see, that's not the case either. And Gödel, there's no clear ordering of application of definitions of PM. Well, that we're going to find out is false as well. So if you just do a little sweep here of some of the most famous interpreters, we're going to find that they're not the case, even though today I want to focus on Quine. Now, Church tried to notice these kinds of things and tries to make modifications that would, save the day. So we might try again using Church. So he will introduce a predicate variable here with a different order anything above the order of the type, simple type. And then he has an algorithm. Well, we know the algorithm for defining the order of the simple type is simply to count parentheses, +1 for each left, -1 for each right, and the highest number reached is the order of the simple type. So the Church introduces predicate variables, bindable variables, where the order n can be higher than the order of the simple type. For example, n in this case could be greater than 1. It might be 2, 3, 4, 5, or any number above 1 or equal to 1. But then we get the following are logically improvably equivalent. We could have the closure of the WW 12.1. Why did I call it WW? Because it's kind of, let's see if we can fix Wittgenstein's problem, so that we could have it be a closed formula, logically equivalent to the open formula here with the variable. But it still won't yield comprehension. We cannot universally instantiate a predicate variable to a formula. We're going to need Church, uniform substitution of suitably ordered formula for a free predicate variable, or we'll need to introduce a predicate term forming operation such as lambda abstraction or circumflex predicate formation and find a concretion axiom. Again, to Quine's credit, Quine points this out in his set theory and logic and its logic. So if we had a circumflex forming operation, we could form this kind of a complex predicate. And if we had a concretion axiom schema, we could say that X has that complex predicate just in case X is X. So then what we could do is just, when we instantiate, we could instantiate to the complex predicate expression and then use concretion to get where we want so we can get some value out of having WW 12.1. But here's the rub. None of this is found in Principia Mathematica. There's no bindable predicate variables of the sort that Church introduces. And that's said on page 165. Bernie will remember having a discussion with me about this in the past. But and circumflex is explicitly said in the work not to be a predicate term forming operation. You can find that on page 19. And Church knew it too, by the way. When Church does his work, he says, okay, this is not the actual historical Principia. But it gets worse because Church's orientation would undermine the definitions of the no classes theory at star 20. And you'll find 20.07 where you have this introduction of how to use a lowercase Greek, a bindable lowercase Greek, as if it were, quantifying over classes. And he gives this definition. But the trouble is that the F here cannot be a object language bindable predicate variable. Otherwise, the scope would be forced to be primary. And in fact, it's quite clear if you just look at the proofs in the no class theory that the scopes are allowed to be secondary or smallest. And so, for example, the definition here, when we have a universal quantifier, lowercase alpha, you see you get secondary scopes of the class term in the side of this. So the F allows for secondary occurrence. Church presents F as a bindable predicate variable, and this forces a primary occurrence. So if you followed Church, it would have to look like this. And if it looks like this, the no classes theory will not work. If you go through the proofs, you'll see that that's not the interpretation that's given to it. Now, Church is very smart. He's a logician, top-notch logician. I'm sure he could fix this problem by having some kinds of new parameters concerning rules of uniform substitution or something like that to try to dance around the problem. But there's no such dance in Principia. In fact, nobody in Principia, you're never going to find any rule of uniform substitution whatsoever. So it just looks straightforwardly like the phi, psi, f, g, and so on in Principia without the exclamation are schematic letters, and with the exclamation are the object language bindable predicate variables. Okay, but today we're trying to focus on Quine's misrepresentation. So I wanted to start with some nice things that Quine says and notices, and then go into his, so we can clearly know that he understands these things, see what he says about Principia himself. So I have two pictures of Quine here. Can you see it? They're sort of looking at one another, and I thought that was kind of fun because one would think that Quine knows what he's doing here, obviously. But what is he doing? Of all people, he ought to know what's in Principia. His PhD dissertation was directed by Whitehead and concerned Principia itself, which he regarded as a book that was most important to him. He wrote a book, Set Theory and Its Logic. He tells us about Principia in several places, and he also speaks about it in his Whitehead and the Rise of Modern Logic, which is in the Shope volume on Whitehead. And he talks also in Russell's Ontological Development. But I want to demonstrate that very often, and in crucially important ways, what Quine says in Principia is demonstrably contradicted by Principia itself. So what are we to conclude? Should we say Quine actually didn't read it? Or at best, perhaps he thinks himself to be offering a charitable interpretation of what ought to have been in Principia by pretending to speak about what is in it? I don't know how to explain what's going on here with Quine. Okay, so let's take some bullet points. There's 6 of them. I could add more, but let's take 6 of them in turn and take a look at what he says and then its negation in Principia. And some of them might sound a little technical and so on, but don't worry too much because all we got to do is recognize that there's a negation of it in Principia. Right, so we can sort of recognize a negation even if we might not know the details of what the content is. 1, the theory of attributes receives no application for which the theory of classes would not have served. That's a famous one from Quine. 2, the numbers cease to be unique. A unique 0 appears for each type. Likewise, a new 1, and so on. 3, the special principle of Russell's theory is just that of concretion. We already talked about that one, and I gave you the quote where they deny that circumflex, well, we'll see the quote, is a term-forming operator, is explicitly denied. But in any case, concretion. But then here's a fun comment that Quine makes. Again, it must, in justice to Russell, be said that he was incommunicative over these matters. Well, we're going to see that he wasn't, or Whitehead and Russell wasn't incommunicative. They explicitly say circumflex is not a term-forming operation in their own language, of course. 4, classes are said to have the same cardinal number just in case they are respectively the domain and the converse domain of a 1-1 relation. We're going to find that it's explicitly rejected in Principia. That's Hume's principle, and Hume's principle has instances that are false, and it's said explicitly. 5, if one type is finite in its membership, each is, and then proper arithmetic is forthcoming in no type. Again, false. We'll find a passage where Whitehead explicitly says that the cardinal number of one type, if you like, a universal class of a particular type of individuals, does not determine the cardinal number of the universal class of individuals of the next higher type. And then the first infinite cardinal, aleph null, is defined as the cardinal number of the class of all finite cardinals. Again, we're going to find that that's explicitly said to be false. That's how Cantor defined it, but Whitehead and Russell do not define it that way. In fact, they discovered something very important, that the notion of a smallest Dedekind infinite class does not rely at all on the notion of the inductive cardinals or the natural numbers. So let's take a look at details and see, point and then counterpoint. So the first one, the theory of attributes receives no application for which theory of classes will not have served. The first among Quine's remarks is particularly grievous. Quine ignores the revolution in mathematics against abstract particulars that Russell, in his 1901 Mathematics and the Metaphysicians, so earnestly endorsed. Obviously, for Whitehead and Russell, the acceptance of universals is not a mere preference. It's the raison d'etre of the revolution within mathematics, and it is developed and defended in Principia against the metaphysicians of abstract particulars. Whitehead-Russell logicism endeavors to undermine the metaphysicians' arguments for the indispensability of abstract particulars in the branches of mathematics. Universals, well, that's odd. I don't know, I put a hyphen there, but properties and relations in intension are in good standing, while abstract particular numbers, geometric figures, classes, sets, etc., were all imposed by the fallacious arguments of the metaphysicians for the indispensability of abstract particulars, and often they had them be governed by distinctly non-logical necessities that are arithmetic or geometric or metaphysical. In point of fact, Quine's first remark presumes his own philosophical orientation, according to which whatever is particular. He imposes his own theory of sets and set membership. We may call them Quine sets to distinguish them from Zermilo's sets. So by ignoring the revolution within mathematics, which is really heralded in his own way in that paper, Mathematics and the Metaphysicians, Quine promotes his own agenda. He's not telling us Principia's agenda, he's promoting his own. 2, the numbers cease to be unique, a unique zero in each type, and so on. In Quine's New Foundations for Mathematical Logic, we also find this. And Quine offers the following, which he included in his contribution to the Schill volume. Even arithmetic, Quine says, when introduced by definitions on the basis of logic, proves to be subject to the same reduplications. This is Quine speaking. Thus, the numbers cease to be unique, a unique zero for each type, likewise a new one, and so on, just as in the case of universal, class, and anti-class. Not only are these cleavages and reduplications intuitively repugnant, but they call continually for more or less elaborate technical maneuvers by way of restoring connections. Well, the reduplication is indeed repugnant for any metaphysician of numbers as abstract particulars, or anyone who holds that arithmetic requires a system of abstract particulars. But in Principia, there's no reduplication of numbers simply because there is no ontology of numbers to reduplicate. There's no ontology of numbers as abstract particulars, and there's no ontology of numbers as properties either. Numbers are not identified as properties in Whitehead-Russell logicism. Properties are intentional entities, and mathematics is entirely extensional. And now, Russell wrote, this is from Our Knowledge of the External World, if the theory that classes are merely symbolic is accepted, it follows that numbers are not actual entities. There it is, quite explicitly put. Okay, let's go on to number 3, which is we've already sort of talked about. That's the concretion. And his third comment is demonstrably false. Indeed, far from being incommunicative, Whitehead and Russell communicated very clearly that circumflex is not part of their formal work. And here's the quote, page 19. In fact, we have found it convenient and possible, except in the explanatory portions, to keep the explicit use of symbols of the type phi x with the cap, where remember phi would be a schematic there for a formula, and you just put like you cap some of the variables in it. Would you keep that expression either as constants, for example, being equal to a, or as real variables, almost entirely out of the work. The introduction of circumflex is a predicate term forming operator, and the introduction of a concretion axiom or axiom schema is a fabrication of well-intentioned logicians endeavoring to fix the work. No axiom schema of concretion can be found anywhere in the formal system. Now, I learned this first. I should give credit to William S. Hatcher. He has a wonderful book called The Logical Foundations of Mathematics, and he pointed this out first. That doesn't stop well-meaning logicians from adding it in their interpretation of Principia. Okay, if one type is finite in its membership, each is, and then proper arithmetic is forthcoming in no type. Quine's fifth comment is explicitly refuted by Whitehead in the opening of Principia's Volume 2, where we find him noting that a given universal class of individuals of a simple type being frege finite does not assure that the universal class of individuals of the next higher type is also frege finite. A class is said to be frege finite, of course, when it's a member of some inductive cardinal. Let's rehearse Whitehead's revealing comment. This is what we find in the intro. PM, Volume 2, Roman numeral 7. Given the number of individuals, there is nothing in our axioms to show how many predicative functions of individual, whoops, I left out the plural. There's nothing to show how many predicative functions of individuals there are, i.e. their number is not a function of the number of individuals. We only know that their number is greater than or equal to 2 to the cardinal number of individuals. Now, Whitehead uses this notion of individ, because they took a vow never to assign simple type symbols to anything. But if we put it in a much more accessible way, using little simple type letters schematically with little t's and t's in brackets and so on, we can have this be called Whitehead's universe theorem. It's probably one of the most important things that's come out of the new research in Russell studies, Whitehead-Russell studies. What this theorem says, of course, they don't actually prove it because you'd have to restore simple type indices to prove it. But what it's saying is that the homogeneous cardinal number of the universal class of individuals of that are either equal to x to the t, where that's the type in brackets, or not equal to x to the t in brackets, is greater than or equal to 2 to the cardinal number of the universe below it. And this is a very important result. And it shows that, remember, that individual is a technical term in Principia. You've got universal classes of individuals, as well as notions of constructions, emulations of set theory. But of course, none of the classes or sets constructed are individuals at all. But you've got simple types of individuals going on here, I want to maintain. And you see the type of one, how many there are in the one, is not determining how many of their type in the next type up. Unlike the Cantor case, the power class. So it's very important. 4, classes are said to have the same cardinal number just in case they're respectively the domain and converse domain of a 1-1 relation. Okay, that's false. Whitehead and Russell do not accept Hume's principle. That's what this says. The cardinal number of alpha equals the cardinal number of beta if and only if alpha is similar to beta. This is not found in Principia, and here's a quote. Okay, I have a typo, sadly, in this biconditional should be a conditional sign because I quote you right below it what he says. Going the other way is not always true. If the cardinal number of alpha and the cardinal number of beta are descending cardinals, we may have that the cardinal number of alpha is empty and the cardinal number of beta is also empty without having alpha being similar to beta. So sorry about that typo. This biconditional should just be a horseshoe going in the one direction, and going in the other direction is not always true because it's not true for descending cardinals. Okay, so it's just refuted outright in Principia, page 15, volume 2. 6, the first infinite cardinal, Aleph null, is defined as the cardinal number of the class of all finite cardinals. But in Principia, we see that that's not how it's defined at all. And in fact, in Principia, we see star 105-27, which says that the empty class is a member of the class of descending cardinals. This theorem says that the empty class is a descending cardinal number. In point of fact, this is an important theorem in Principia. It plays a role in the argument that Aleph null, which is the cardinal number of any smallest Dedekind infinite class, isn't itself a cardinal number. By definition, a class is Dedekind infinite if and only if its members are not in 1-1 correlation with members of a proper subclass of itself. So this theorem, 105.27, plays a role in assuring that even if Aleph null should be empty, we have the result that Aleph null is either a descending or it's a homogeneous cardinal number. And this was not some sort of sordid workaround required only by a flaw in Whitehead-Russell logicism. It was a new and important discovery of revolutionary mathematics. Whitehead and Russell discovered that the notion of a smallest Dedekind infinity does not require the inductive cardinals to be the paradigm. So this Cantor was wrong. And that's an achievement. It's not a flaw, it's an achievement. It's not a workaround. So now these are my last two quotes, getting very near the end, but they're a little bit small probably on your screen. So forgive me, I'll just try to quickly, give you the gist of what's being said here. These are my words now on behalf of Russell. You may disagree with my words on behalf of Russell, of course, but here's my words. In all discussions of Principia's logicism, its formal work defending the revolution with mathematics must be kept front and center. It's going to be a theme of my Principia Mathematica redux. Otherwise, the important implications of the revolution are apt to be misunderstood and inadequately regarded as failings of a program of rational reconstruction. Principia's discussion and characterization of Aleph null is an important case in point. Quine blithely assumes that the Dedekind infinity of the inductive cardinals is involved in capturing Cantor's Aleph null, which is the cardinal number of any smallest Dedekind infinite class. But Principia reveals that the notion of a smallest Dedekind infinity, such a class, does not rely on the inductive cardinals being the paradigm. This is not an embarrassment or failing. I'm repeating myself now. It's an achievement. It stands independently of whether or not the class of inductive cardinals is in fact Dedekind infinite. It's a discovery of revolutionary mathematics. It's misunderstood and often misrepresented as if it were an unfortunate and untenable consequence of the inability of Principia to prove the Dedekind infinity of the natural numbers, and thereby make good on its alleged promise of rational reconstruction. But no such rational reconstruction was promised or required by Principia, and the metaphysicians, guided by their intuitions of abstract particulars, have lost their authority to make postulates concerning alleged necessities governing numbers. The Dedekind Peano postulates, once thought by the metaphysicians to be arithmetically necessary of the natural numbers, have lost their authority. Here's the proof right here in the middle. If you can see my pointer, there's how it's defined. First, you define the notion of a relation being a progression, and then you take the domain of some or other progression relation. Whitehead and Russell discovered that the notion of smallest Dedekind infinite, called Aleph null, does not require the metaphysician, as the metaphysicians thought, the class of natural numbers to be the paradigm. We're going to see that they're not the only ones. You're going to find that Quine thought that Boulos thought that. Boulos makes heavy weather about this in a paper, accusing Russell of theft instead of honest toil, when in fact he just doesn't understand what's going on. According to Principia's defense of the revolution in mathematics, the notion of a natural number does not derive from intuitions introduced by the Peano postulates. It derives from the ancestral relation and the notion of ancestral induction. The natural numbers are thus properly understood as inductive cardinals. That's why they get their name. Cardinals obeying induction. Nothing here assures their infinity. Now, maybe they are infinite, but it doesn't get assured by the notion of an inductive cardinal. If they are infinite, it must come from a different source or a different quarter. Accordingly, the inductive cardinals should not be the paradigm for the notion of a smallest Dedekind infinity. In order to capture the notion, as we just saw, we got star 123.01. Look it up. Whitehead talks about it in English right before he does the definition. As we see, Aleph null is defined as the class of domains of some or other relation in extension that has the property of being a progression. If we're talking about relations, relations in extension, that is a progression whose domain consists of individuals of some or other simple type. Whitehead puts Aleph null, and then he has in brackets X. that already shows you that there might be aleph null many individuals of simple type, of that simple type. It is to be a relation E that is a progression whose domain consists of classes. If that's the case, then we have aleph null with the big brackets with an alpha in there. Oddly, Boulos, in his 1994 paper, didn't appreciate the definition, since he didn't appreciate or accept the revolutionary view, or even know about it, that the characterization of aleph null should be independent of the notion of the inductive cardinals, even if the class of inductive cardinals is Dedekind infinite. Principia reveals aleph null should be characterized as the cardinal number of the domain of any relation E that has the property of being a progression. The notion of a progression is tied to the notion of Dedekind infinity, and the notion of the inductive cardinals is not. Principia reveals how to capture the notion of smallest Dedekind infinite without the metaphysician's postulation of an arithmetic necessity that there is a class of abstract particular natural numbers that are Dedekind infinite. This is itself an excellent example of what Russell lauded as honest toil over theft. The Peano postulates, once again, constitute theft, since they are driven by intuitions of a distinctively arithmetic necessity governing natural numbers as abstract particulars. And then, of course, Whitehead-Russell logism is supposed to realize or rationally reconstruct that notion of the necessity of the infinity, Dedekind infinity of the natural numbers. Okay, almost done. Last slide. The domain of any relation that's a progression is Dedekind infinite, thereby Frege infinite. The property of being a progression can be studied a priori, independently of any contingencies of whether any relation is a progression. This is illustrative of the revolutionary orientation to studying relations independently, whenever one can, of their exemplification. Dedekind Peano postulates were written by metaphysicians of mathematics who view natural numbers as abstract particulars and regarded it as a distinctly arithmetic necessity that the class of natural numbers forms the smallest Dedekind infinity. For such metaphysicians, a rational reconstruction of the Dedekind Peano postulates is required for any hope of success of any logicism. In stark contrast, the revolution within mathematics abandons the metaphysicians and their methods of postulation. Russell calls it theft over honest toil. Their postulations were based on their intuitions of abstract particulars governed by arithmetic or geometric necessity. Okay, so summary in a way. The revolution with mathematics is not logicism. It holds that the branches of mathematics study relational structures by studying properties and relations independently of any contingencies of their exemplification. Frege's revolution in logic was that logic embraces comprehension, impredicative comprehension. But that's not logicism either. Frege's logicism is defined as his thesis that numbers are logical objects. Frege's logicism rejects the revolution within mathematics. Frege requires the existence of a second-level 1-1 correlation function with purely logical objects, which was his downfall. Whitehead-Russell logicism is antithetical to Frege's logicism, since it accepts both revolutions. Whitehead-Russell logicism is the thesis that revolutionary mathematicians are doing CP logic when they do mathematics. There's no reduction, there's no other field, there's no rational reconstruction. They're telling us what mathematics really is, and it's saying that the mathematicians figured it out themselves. Whitehead-Russell logicism does not require simple type freedom, since every relational structure can be captured within simple type scaffolding. And we learn that from Russell's substitutional theory, because he was perfectly happy to recreate the whole mathematical structure within the substitutional theory, which is a theory that emulates simple type structure. So Whitehead never accepted Russell's hopes of eliminating, or never needed to accept Russell's hope of eliminating simple, types of individuals, because it in no way inhibits the defense of the revolution in mathematics. Okay, last slide is this picture. And it really seems like I'm attacking the orthodoxy. So I took this picture years ago of a tornado that hit the Catholic church in town. And it was one of the most beautiful churches. Of course, we're way out here in the Midwest, but for Midwestern churches, it was so beautiful. And and some of the parts of the community wanted them to rebuild it, but they gave up and built a very pedestrian church with all the money that they got from the insurance. But this church was really quite loved. And just as the orthodoxy in interpreting Russell, I suspect there's quite a few people out there that love that orthodoxy. So I'm sorry, I'm attacking that orthodox interpretation. I don't see any way to save it. That's my apologies to those people if I've stepped on anybody's favorite interpretation of Principia. I think we have to read Principia anew. I'm writing a book on it to try to do just that and to present it as a defense of a revolution within mathematics and a revolution within logic. The revolution in logic says that impredicative comprehension is part of logic. The revolution in mathematics is that mathematics is about relations and properties, not about abstract particulars of any kind. Both revolutions are independent of logicism. But Russell and Whitehead put the two revolutions together, and that's their logicism. Okay, thanks very much.